Hello. Hi, everyone. I'm Prabal. I'm one of the co-founders of Avail. And today's topic is about the seamless horizontal scalability across the Ethereum ecosystem. I think the talk is pretty pertinent today, right? And although we see quite a number of rollups as of date, I think almost 3 years back when we started working on the interop piece of the Avail stack, we could already envision so many rollups being actually used in production. And we were thinking like, how can we think of the solution from the grounds up? What are the key necessary components to provide a seamless experience? What does horizontal scalability mean for a rollup-centric world? And how do we connect them all up in terms of scale, in terms of interop, in terms of security? And from then on, we went on to this journey of what we know as Avail. I think I don't need to convince you guys about this one, right? That the status quo right now that we have is extremely fragmented. You can see a lot of these chains, and you can see, I think this is only a few of them that we have been able to show. And every day we think about newer chains coming up, and that is an amazing thing to happen inside the Ethereum ecosystem. That is the designated way to scale blockchains. Every ecosystem of their own merit are creating these healthy ecosystems of their own chains. And a huge plethora of apps are getting built on each one of them. And we are seeing innovation every day. I think yesterday also, Robinhood announced another L2. I think that is the way we are going to see this blockchain industry evolve in the coming days. But with that comes a lot of L2, L3 rollup, however you want to define it, and a lot of bridges, right? If you think about how blockchains do talk to each other today, it is a mess out there. Depending on what kind of solution you're looking at, whether it's an L2, it's an L3, what kind of settlement layer, what kind of ecosystem, what kind of virtual machine, what kind of compatibility with the existing tooling, and a host of the other features, these rollups are different to one another. And connecting homogeneous components together is easy. Connecting heterogeneous components together in a secure manner becomes tough. And that's where you see like a huge number of bridging solutions that are out there. Each one of them have been amazing for the ecosystem. They have been able to connect us and connect the chains together. So we as users don't have to worry about how do we take the funds from one to other and so on. But with more chains becomes more liquidity fragmentation. When liquidity is spread across many different chains, the UX on top of it gets extremely complex. A dApp developer has to think about which chain do I deploy on, what is the security of that, what are the tooling of that, what is the developer support of that, but what is the kind of TVL of it, what kind of ecosystem is built around it, what are complementary apps within the ecosystem that I can get support from, and so on. And this kind of UX complexity leads to trust assumptions being added in terms of interop. So we see that sometimes the interop players are providing questionable security. Sometimes there are some heavy trust assumptions that we are taking when we are bridging funds from one to the other. This kind of interaction leads to weaker composability and capital inefficiency. I don't need to convince you about that probably. But when in a divided world where there are silos of security and interoperability, it creates a lot of fragmentation, which is the vicious cycle that we are in. This is what limits us today from being able to develop an economic flywheel within the Ethereum ecosystem. Level one, this was how we did it, and we are still doing it. This is a dominant way to connect chains together. This is the state verification based lock and mint type bridge. Again, you may say that this is not always state verified. Sometimes it's events which are verified, etc., etc. You can say it's not always lock and mint. There are other types of bridging protocols out there. But generally speaking, the class is that I lock it on one chain, verify the locking on the other one, and then mint corresponding assets or corresponding wrapped assets. The second way is to basically abstract the bridge complexities. The first one is purely bridge specific. The second one is how do we abstract it out? We provide liquidity. I will come to this liquidity based approach a bit, but jumping ahead, there are the solver based bridging approaches which are coming up right now, which is essentially trying to abstract not only the bridges, but actually it's trying to abstract chains from the users. And that is the dominant way we are seeing. This is more like a hybrid approach between the first two ones, and that's what we are seeing more and more today. I think this I already have kind of explained, right? So you have something like an optimism and something like an arbitrum. Take any two chains of your choice. Like it really, really doesn't matter in this context, but it matters a lot in terms of the security context when you go from L2s to between an L1, between two L1s, between an L1 and an L2. All these things have various different meanings in different settings, and they are not the same. Although we are being made to think that they are the same, that when you talk to two different L2s on the same settlement layer and on the same DA layer, they are the same as to talking to two different L1s, which have varyingly different security modules and consensus protocols and light client verifiability and so on. They are not the same. But this is the dominant one that we see right now. This is the lock and mint protocol. I cannot proceed to the next one. Yeah. But this leads to this kind of a situation where there are huge number of wrapped assets lying all around. Every chain, every bridge does it in their own way. It creates a lot of problems. I will also try to mention that it is not that no one is solving this problem. I think a lot of these guys have done an amazing job in creating something like an entity or an OFT or these kind of protocols which are solving these kind of fragmentation issues across the board. But still, the situation is not that great. Liquidity-based bridges, easier, right? It's very simple. You guys probably know it all. You take a pool, you have the funds, you cross it across two different chains, you have a centralized manager, you can decentralize it as well. It is not that big of an issue. The user submits fund onto one pool, you listen to it, you drop the corresponding funds. This is again what it's leading to. It's a leading solution right now across the space. It gets the job done. The capital is needed upfront, so someone is upfronting the capital on your behalf, but it gets rebalanced. On major corridors of fund transfer, this may work if it is bidirectional and such. When things get omnidirectional, when things about the long tail of rollups that we talk about, this doesn't solve the problem too much. It gets costlier, it gets capital inefficient for the LP provider. And we are seeing again and again a solver-based approach. What it is saying is that, again, no need to think about the entire flow here, but as a user, I want to do an action. Someone says, I can fulfill your action. I am saying, okay, I sign the attestation that if this action gets fulfilled, then I'm going to pay you. And then this happens across multiple different chains. The solver is doing the coordination. And this is the simplistic view of how different solver-based applications work today. But in reality, there's a lot going on inside these solvers. So we try to classify, we try to think about it from the grounds up, like, okay, how does this solver-based protocols work? What are the different problems that they have? What are the different solutions that they have come up with? Why are these solver-based techniques different from one another? If it is all that simple and that we are just doing this entire coordination bit, then what is so tough about it? Why is it that there are at least 5 players and much more really who are trying to solve this? We try to break this into different parts. The first part is the state keeper. Think of this as whoever is the orchestrator of the protocol. Now, when we saw that who maintains the order, you might think like, okay, there are 2 chains involved, so you need to do an action on one chain, do another action on another chain, and then just synchronize their views. It's not that simple, right? Because depending on where you keep the state, the protocol inherently becomes different. So there are things like players like Across who have done fantastic job in the space, who are keeping the state on chain. So they keep all the states on chain and then have another part, I will come to it, to coordinate between them. but there are others who are keeping the state off-chain. Keeping state off-chain is actually a good and a bad thing. The good thing is that you do not need to pay gas fees in the initial opening of the bid. But the bad thing is you need to trust on that off-chain entity for the security of this. Then there is an executor. The executor is basically, think of it as the settlement layer. The settlement is whoever is providing the custody or saying the custody provider, and the escrow, what is the release rule of this entire protocol. We have the state verifier. I know I'm talking about jargon at this point in time. Why do we need to classify it? But this is where the things get very interesting. How do you coordinate cross-chain? This is one of the fundamental problems around which the entire interop hindrance starts, right? So you have states across two different chains. How do you synchronize the two? If you could have a simple way to synchronize state across the plethora of rollups that we see today, I think it was a problem solved. The problem is that it is hard. It is hard because every state tree is different. Some of the state trees have been modified in order to become ZK provable faster and so on. There is lack of EVM compatibility all across. There are now SVM rollups and other VMs, very good ones, which are coming up, which have different optimizations in terms of read-write efficiencies, in terms of Merkleization of it and verification of it. So how do you coordinate cross-chain? And we saw that, optimistic Oracle model is one of the more dominant ones out there. So what you do is you assume that it is correct. You take it in good faith that it is correct. You go ahead. If there is a problem, someone raises it, we will see. We will see by either social coordination or something else. But that is the dominant protocol that you are doing today. So even when you are getting your funds upfront, there is a chance that there was a problem and you wouldn't know about it unless a time elapses. And that's where we started digging, right? So we started digging that, okay, this status quo is not that good. What can we do to make it trust minimized? Because what are blockchains if they are not trust minimized, right? So we think of rollups as verifiable servers, and then if you do not have good coordination between verifiable servers, then probably you're not doing that great being in a blockchain at all. So we started working on TEs, we started working on ZK-based attestations and such, and each of them have their own trade-offs. I will not go into the trade-offs right now, but happy to discuss it off stage to see what are the different kinds of problems that we come here. The escrow bit is the most basic bit. It is the fundamental primitive which we use day in, day out in blockchain protocols. And it's just that someone needs to hold the funds, they need to release the funds based on some logic. Who determines the logic? The executor determines the logic. The cross-chain verifier fuels the executor to determine the result on when the escrow releases the funds. But one main thing is that you cannot do it using EOAs. It is probably a very, very bad strategy to do it using EOAs. Some people do that as well. But that's something that we wanted to avoid in all cases. And then, of course, we need the solvers. I think you guys know it a lot, that there are off-chain entities which are trying to fight among themselves to provide you the best rate, to provide you the fastest way in and out of chains. And they are the actual blood inside this entire organism, which is keeping all of this together. They are the main actors in the protocol. And we try to classify all of this. And again, I will be very, very honest. This is not an exhaustive list. There might be some of your favorite protocols which are missing who does interop in a solver-based mechanism, but we haven't been able to cover it. But to the point where we try to cover, if you can see, there are various ones, and each one of them have done it, thinking about some trade-off. So none of this comes without a trade-off, right? If you think about across, they keep state on-chain, they keep the executor off-chain, but with an UMA-based dispute resolution mechanism. Their cross-chain verification is again optimistic, and the escrow is essentially a part of the protocol. There are others who keep this pluggable, you can make the escrow part of the protocol, not make it part of protocol. You can use others. There are others who use something like an AVS or MPC for cross-chain verification. We saw this and we thought that we need pessimistic proofs. We need attestation, we need better security guarantees in each one of these columns. And that's where we come up with Avail Nexus. The Nexus aims to abstract all of this complexity. To be honest, I will show you in a bit that you don't need to remember any of this. All of this is happening on the back end. We think of Nexus as a class of protocols which is trying to abstract all of this out. But what does it lead to? Leave me the jargon, give me what the use case is. So I present you a demo about how Avail Nexus would feel like for the end user. I would ask someone to play the video here if they are there. Yes. So this is how Aave feels like when you don't have funds on that chain. So you go to another bridge, you go and deposit those assets, you do the swap, you then do the bridging, you have those bridges, you have another funds on another chain, you take that, you swap that, you then go ahead and go to the Aave front end, you deposit USDC, you submit, and this is all done, right? So this is the flow today, 23 clicks, almost 10 steps, 3 transactions. This is the status quo, and this is what we are trying to build. We are trying to build that this will be a pluggable SDK integration on the front end, which will take your assets from multiple different chains, all in 1 or 2 clicks, and it will go ahead and deposit it directly. As a dApp developer, this is the usability you want. You want 3 clicks, you want 1 transaction, you want full 7702 compatibility, you want to be as compliant to 7683 as you can be, and you want this entire intent-based framework to work out without you having to care anything about it. So that's the Nexus SDK. That's what we are working hard on to solve the interoperability and the fragmentation issues of Ethereum and to provide a cohesive experience across the Ethereum ecosystem, no matter what kind of rollups you're using. If you're a developer, reach out to us, try out the SDK, let us know how you like. Thank you, that's me. I think I have a minute left if there is a question or something. Only one question. Yeah, Avail has its own validator set, but that's for the more of the DA layer that we have. So the base layer, which provides, blob space to rollups, that has its own validator set. We have around 105 validators running today with one of the highest Nakamoto coefficients that are out there. So that is, the validator set is there. On the Nexus side, we depend more on ZK and TE attestations rather than validator based. That's at least the thinking on the state keeping and the state synchronization bit. If someone uses the same DA layer for cross rollups, then they can get much better guarantees in terms of interop. Yeah, so different chains have different kind of security modules. So for example, if you have a ZK rollup, your source chain is a ZK rollup, then you have a ZK proof of its state attestation. But the same for optimistic rollup, you do not have that, right? So there we are using a TE-based security. So what we are trying to offer is we are trying to develop a class of protocols and offer the developer to choose what kind of security that they want. Because to be honest, users don't care about security. They trust this application, they want to use that application, and they want to actually integrate with it, right, and use that. The developer needs to do the trade-off analysis, needs to choose till what security do they want to accept, and according to that, they can use it. I think I'm out of time, but thank you.